In this video, you are going to learn how to find the shortest distance of a point and a circle. Look at this example. We need to find the shortest distance of a point P, -6, -8, and the circle C. First of all, we need to determine whether point P lies inside or outside the circle. We need to compare the distance between point P and the center with the radius of the circle. We can use the formula -d/2 minus e/2 to find the center. So from the circle equation, we know d is -6 and e is -8. So the center of C is equal to -6/2 minus -8/2. It is 3, 4. Let h and k be the x and y coordinate of the center. So the radius is square root h squared plus k squared minus f, where f is the constant term, that is -75 in the equation. So we can use the formula to find the radius, that is square root 3 squared plus 4 squared minus -75, which is square root 100, and that is 10. Then we can use the distance formula to find the distance between point P and the center of C. It is square root 3 minus -6 squared plus 4 minus -8 squared. It is square root 225. It is equal to 15. So notice that distance from center to P is greater than the radius, so point P lies outside the circle. Since point P lies outside the circle, we can find the shortest distance by doing subtraction. That is OP minus the radius. It is equal to 15 minus 10. The answer is 5. Let point Q be a moving point on the circle. You may want to ask why we simply do the subtraction OP minus R to find the shortest distance. Why is there no other point on the circle, such as Q1 or Q2, nearer to the point P? The reason is very simple. We can prove it by using triangle inequality. The triangle inequality says the sum of any two sides of a triangle must be greater than the remaining side. Now we join O and Q1, Q1 and P to form a triangle OPQ1. By triangle inequality, OQ1 plus Q1P must be greater than OP. Also notice that OQ and OQ1 are the radius of the circle. We have R plus Q1P greater than R plus QP. Cancel R on both sides. We have Q1P greater than QP. Based on this argument, if there is another point, say Q2, it's not on the straight line OP. The distance between P and Q2 must be greater than PQ. Therefore, only when O, Q, P are collinear, Q is the nearest point to P. Let's consider another situation. Now point P lies inside the circle, and Q is the moving point on the circle. We also have the same result of finding the shortest distance. That is, the point Q is nearest to OP when O, P, Q are collinear. But the shortest distance is a bit different. In this case, the radius is longer than OP. So we should use the radius minus OP to find the shortest distance. We can also use the triangle inequality to prove that if the 3 points are not collinear, say the points Q1, P, and O, PQ1 will not be the shortest distance. Look at the triangle OPQ1. We have OP plus PQ1 greater than OQ1. Also note that OQ and OQ1 are radii, so OQ1 is equal to OP plus PQ. Therefore, OP plus PQ1 is greater than OP plus PQ. Cancel out OP on both sides. PQ1 is greater than PQ. So in conclusion, when we need to find the shortest distance of a point and the circle, always remember the 3 points, the center, the point P, and the point on the circle are always collinear. Let's do the conclusion. In order to find the shortest distance of a point P and a circle, first, we need to determine whether point P lies inside or outside the circle. If point P lies inside the circle, we use r minus OP to find the shortest distance. If P is outside the circle, we use OP minus r to find the shortest distance. To determine whether point P lies inside or outside the circle, we need to find the center and the radius first. From the equation, D is negative 10, E is negative 24, and F is negative 231. So the center of the circle is minus negative 10 over 2 minus negative 24 over 2. It is 512. The radius of the circle is square root 5 square plus 12 square minus negative 231. It is square root 400. The radius is 20. And the distance from the center to the origin is square root 5 minus 0 square plus 12 minus 0 square. So the distance is 13. Because the distance is smaller than the radius, so P lies inside the circle. So to find the shortest distance from the origin to the circle, we use the radius minus the distance from the center to the origin. That is 20 minus 13. The answer is 7. This is the end of this video. Thank you for watching.